Hi, the purpose of this video is going to be to show you some very common and useful functions using Google Sheets. These will be the same types of functions available in pretty much any database. You'll notice I have the function name listed here, a quick description of what it does over here, and some data. So what I'll be doing is building examples in this spot. The first function I'd like you to look at is concatenate. So concatenate simply means to join together. As with all functions, you start with an equal sign. You can choose it, and then I'm going to pick the first thing that I'd like to concatenate, type in a comma, and a comma is just the way we add in different parameters or different values. So now I'm going to click the second one. So there I have John Smith, and it comes up John Smith. The only issue here is that I really wanted to have a space between them. So in order to do that, in order to put a space into this, you simply put a set of quotes, a space, and another set of quotes, and a comma. So basically what I'm doing now is I'm saying take the value of A2, then take this blank space, then take the last name. And when I hit enter there, I get what I want. Now, it doesn't have to just be a blank space. You could put any kind of text in between here, and that would be your way of adding it into this particular value. Okay, the second function is left. That's very simple. If you happen to know how many characters from a string you'd like from the left, you can get those simply by saying, always the equal, left, this is the string, and I would like the 5 characters to the left. I'm not even going to close the parenthesis. If the close parenthesis is the only thing that's missing and you hit enter, Sheets will figure it out. So I could extract the area code from all of these numbers. Right works very much the same way, but from the other direction. So since I know in a phone number the last 1, 2, 3, 4, 5, 6, 7, 8 characters will be the rest of the phone number, provided it's entered in this format, I can just simply say equals right. This field 8. And I get the rest of the phone number. Okay, as far as length, if I want to know how many characters are in this entire string, I can just type len and pick the text field or the number field. It'll tell me how many characters are there in total. This is particularly useful because you can use it in combination with other functions. Like I can take the total length of something and then take the certain number of letters from the right. I'll show you an example of that in a minute. Now, what I'm going to start out with is let me just copy this one down actually. I'm going to copy this down and I'm going to see that this John Smith has 15 characters, or a length of 15. Well, I'm only seeing 4. Space would be 5. Another 5 should be 10. But as it turns out, the way I entered this, I have multiple spaces in here I don't need, and I even have some spaces at the end that are inappropriate. So, this function trim equals trim and the value will eliminate or remove spaces that come before the text, after the text, and duplicate spaces within the text. So it'll limit it to 1 space between words. It's a nice way to clean up data. The next is find, extremely useful. Equals find, and if I click on this email address, I actually am not going to click on an email address yet. I'm going to put the @ sign in quotes and then select the text. So this is saying I'm looking for the @ sign within that bit of text, and it's telling me it's in the 7th position. 1, 2, 3, 4, 5, 6, 7. There it is. Very, very useful because the @ sign may be in different locations depending on the email address. So if I wanted to extract either the domain, the part on the right, or the username on the left, I would need to know that position. Then I could say, I'll show you an example, equals left here. But how much? How much do I want to the left? Well, I can find the @ sign in that text. If I hit enter, it'll get me everything plus the @ sign. Now, if I don't want the @ sign, finding is just giving me a location. So I can just say I'd like 1 less than the total, -1. And that will get me just the username. Okay, I know that can be a little confusing. We've, we're starting to use multiple functions together. We're starting to nest them and put them inside each other. But that's a good example of how that can be done. Now, you could have built that out in several successive steps. So I could have done this, equals find the @ sign in this value, and that's 7. I could have come to the next cell and said equals, please give me the left part of this string. And how much of the left do I want? Well, I want this 7. Oh, actually, I don't want this 7. I want this 7 -1. And that'll get me my J. Smith. Okay, so you see in this case, I simply nested it in one equation, where here I built it out in steps, which is a great way to do it if you're not comfortable with the process in the beginning. It's a great way to build up to it. And then it's just a matter of substitution. I could start adding these back together into a formula. I could start saying, oh, I'm going to take this piece and it belongs, it's the number of characters, and I know where that goes, so I'll stick it in there. Okay, just some thoughts. Whichever way you do it, whichever way you're comfortable is fine. Let me delete that and say, the lower command will simply change everything to lowercase. So there's lower. And now I've gotten rid of the capital J and S. Upper's exactly the opposite. It's going to put everything in uppercase, so I'd like this text to all be in uppercase. Proper is going to make the first letter of each word a capital. So just another text function. Proper this value, and you can see now that I've capitalized the J and the S. Last function I'd like to look at is something called exact. And exact just checks two strings to see if they're exactly the same. So here I have jsmith@email.com, jsmith@email.com. It looks good. So let's say equals exact. The first value I want to compare, comma, the second value I want to compare, enter, and I'm getting false. So there must be something different about these. If I looked a little further, I would have found that I left a trailing space at the end here. So if I take that away, you can see it changes over to true. Now I could have processed both of these emails with a trim function. If you're starting to see how these things work together, you're starting to see a lot of possibilities. Okay, that's a brief look at some text functions. Now we're going to move over to some statistical functions. Okay, you'll notice the function names here, things like average, max for maximum, min for minimum, median, should all be familiar to you as basic math terms. Other functions, such as a series of count functions, large and small, may be less familiar. They're things that are more particular to a spreadsheet. So let's take a look at how they all work. To find the average is fairly simple. We're going to say equals average and select the data we want to average. Now these are actually test scores, so you can see that I have 4 tests. I have 4 people who have taken tests, and so I'd like the average of John's tests only. So I'm selecting that data, and John is averaging an 89. Okay, I can copy that down, and you can see now I have an average for each person in the class. Note in the data that some data is missing. Perhaps someone has to make up a test, and other sections have been excluded, or they're exempt from taking the test for some reason. But not to worry. Sheets is pretty smart. It figures out that these are not numbers and that this should not be included in the average. So an 86 and an 81 does in fact average to an 83.5 when there are only two scores. Highest score is simply a maximum, so it equals the maximum of that same set of data, and the lowest score would equal the minimum of the same set of data. And now you can see high and low scores for John and now the rest of the class. If I were to do those vertically, the same thing, equals max, and select the data this way, and min. What I'm doing now is I'm getting the high and low scores on the test. So in test 1 it looks like there was a pretty significant range, 68 to up to 95. And in some of the other tests there were less of a range. Okay, I can even do that for average. So now it's looking up through this field of data and it's saying that the highest average test was 95.75, or actually the highest average in the class was 95.75 and the lowest average in the class is 76. Okay, down at the bottom we're going to do some additional calculations. I started by typing a 16 in here because I knew I had 4 tests and I knew that there were 4 people, so I expected to have 16 grades. How many grades do I actually have? Well, I'm missing some because some were exempted and some were are not yet filled in. So I'm going to use a function called count. And what count will do, let's select the entire block. Count will tell you how many of those cells contain numbers. And that's great because those are the total grades that I have are those numbers. Now, next function, count A, would be to count cells that are not blank. And its companion is count blank, so they're just the opposite. If I were to put in equals count A and select that same data, I'd get 15 out of 16. If instead I were to put in count blank, I would find the one score that's missing. Now that's not really accounting for the exempted scores, but it's telling me that's the important information of who do I still need to collect and complete a grade for. Okay, the highest score here. Now we could do that as a max, but you'll see that I'm looking for the highest, second highest, and third highest. So we can get the highest, but the other two are a little harder. So in this case, we're going to use a function called large. So we're going to say equals large, and then we want to select the data, all of it. So the largest number in all of these scores, now put a comma, because what we'd like to do is find the largest. So it's the first highest score. Enter, and it picks out a 99, and if you looked here, you'd find that that was true. Now, what I'd like to do is save some time and drag this formula down, but I have to prevent this reference from changing when I pull it down. So I have to lock in this B2 and E5, and you should know that already from previous work, that you need $ in front of the B and the 2 and the E and the 5. And you can get those actually by hitting the F4 key on your keyboard, and that'll just do it for you more easily than having to type it out. Okay, now when I drag down that formula, okay, it's still looking for the first highest score, but I can come into this one and now just edit that and say I want the second highest score, and in that column I want the third highest score. When I get down to lowest score, I'm going to say equals small. I'm going to select the complete data range, and I'm going to say 1 because I want the very smallest value, and that was a 68. Again, lock in an absolute reference for those. It'll just make it a little easier for you instead of having to do it 3 times. And now I can just edit this to say I'd like the second lowest score, and I would like the third score from the bottom. Okay, fantastic. Now we're going to look into a section that's a little more complicated. I want to score between 60 and 70, so I want to know how many of these are between those two numbers, and then I'll do the same for 70, 80, 80, 90, and over 90. Now to do over 90 is the simplest one because it's not a range, so let's start there. And I'm going to use a function called COUNTIF. So equals COUNTIF within this range of data, comma, and now the criterion. What am I looking for? And I'm going to put this in quotes. I'm going to put a quote and I'm going to say greater than 90. And there are 6. Now, just so that you know, if one of these scores happen to be 90, you can do a greater than or equal to by doing exactly that, the greater than sign, and then right next to it the equal sign. But since this says over 90, I'm going to leave it as just greater than 90, and it brings me back 6. Now, a variant of COUNTIF is COUNTIFs, and it just allows you to add more than one criterion. So let's try that. Equals COUNTIFs. The first criterion range, or the criterion range, is here. And now it's asking for the first criterion. So I'm going to put in quotes, I'm going to say if that is greater than or equal to 60, and then a comma, and then the same criterion range, or the same data range. And I can say the other criteria is that it's less than or equal to 70. And scores between 60 and 70 are 1. There's only one of those. Now, I can use my F4 key to lock in or make those ranges into absolute references. Drag them down here, and then adjust this to say 70, 80, and 80, 90. Okay, now you may have noticed a little flaw in my logic here. This really should have been 60 to 69. We can't use 70 in both or 80 in both columns. It doesn't make sense. We're going to double count. But you get the idea how it works. The last thing we're going to look at under statistical functions is this median, and that's going to function as you would probably assume. What is the median score of this set of data? And it's just going to find it for it and display it. Okay, now we're going to look at some math functions. Okay, you should recognize a lot of these, or at least once I explain them. ABS is an absolute value, so it's going to return the absolute value of a number. Even rounds whatever number you have up to the next, or moves it up to the next higher even value. INT returns the integer portion of a number. So if I have 5.5, it'll return to 5. If I have 5.1, it will return to 5 or 5.9. It's not rounding, it's just pulling off the integer and displaying it. You can use LCM on a series of numbers and find the least common multiple. You can find the logarithm of a number. This mod function is going to give you the remainder of a division problem. So if I have 9 divided by 5, the remainder is 4, and it's just going to show me what the remainder is. Odd will show you the next odd number. Power is basically just exponents, so if I want to raise something to the second power or the third power, I use this. Rand will generate a number between 0 and 1, whereas rand between will generate a random number and you can set the lower and upper threshold. So I can say between 50 and 100. Round will do just what you think it does. It'll round the number, and you can designate to what place you want it rounded. Round up will take whatever you have and round it up regardless of the rules. So if I'm rounding 2.1 up to the whole number, it will become a 3. Square root, sum, sum if, and sum ifs. Okay, there's also an average, average if, and average ifs, and these function very much like the count ifs. You know, it works in the same way. It just allows you to add criteria. Okay, let's take a quick look at what's going on here. I've already plugged in these numbers, but we can look at the formulas. So let's just change the color here. So you have 23. I use the absolute value function. I chose cell A2, and it gives me 23. There's the even function. All of these are going to reference the first column or multiple columns depending on what's appropriate. So in this one we use the even function, and even though this is 153, it's showing me 154 as the next even number. If I were to actually type in 154, it would just show me 154. It's not going to go up to 156. Only going to move up if it's an odd number. Okay, here is that int or integer function that we looked at. So here's 44.67. Even though this would round to 45, it just pulls off the 44 because that's the integer portion of the number. Least common multiple of 3, 2, and 9. So I selected the range here, is 18. Okay, this is a logarithm of 12, but logarithm takes a second piece of data, and that's the base. So normally we count in a base 10 system, and that would be the logarithm. But if you were looking for it in an alternate base system, such as binary as a base 2, or hexadecimal, which we often use on computers, as a base 16, you'd get a different logarithm. 23 divided by 9, so that's mod 23a7, and the divisor in the second, it's going to give you the remainder. Odd rounds up to the next odd, so 53 is 53, but if I had 54, an even number in there, it would tell me the next odd number, which is 55. This is showing the first cell, 7 raised to the third power, so 7 times 7 times 7. If we just wanted 7 squared, it would be 2, and now you can see that's 49. This is a random number generator. You'll see that there's a solid number in there. Let me just erase these two for you. And that's because when you use this function, equals rand, and it doesn't take an argument, it just generates the number. Equals rand between, and I'm going to set a lower limit of 80 and an upper limit of 120. Let's see what we get. I got 111. The problem with this is that every time I do a calculation anywhere else, this is going to recalculate. So once you use these, the common thing to do is to copy them and then paste them back in using paste special and do just the values. So what that does is the formulas no longer exist here, so they won't recalculate. Okay, round 26.25 is rounded up to 26.3. Now I did that by putting a comma 1. That means to the first decimal place. I could have put a 0 there, and then it would have rounded to the next whole number. Okay, round up uses the same type of function. I did do this one to the whole number. I put it as a 0. And you can see that 26.24 goes up to 27, even though by rules of rounding it shouldn't. Okay, but I want the next larger number, so I'm using round up instead. Okay, square root is pretty self-evident. This function and put the value in the center, it will give you the square root. So the square root of 137 is 11.704, etc., etc. Okay, the sum function. I simply put sum and selected all the values in this column, and it gave me a sum of 464.16. The next column demonstrates sum if, and that just allows you to add a criteria to your sum statement, just one. So you can see that the way we did that is we picked the range like we normally would, but then I put a comma in and I put the condition. And my condition was that only sum the items that are greater than 0. So I put that in quotes, greater than 0. And you can see that the result here is actually larger than if I'd summed them all, and that's because it didn't include the negative 23. And the negative 23 made the sum lower, but since it's not included, the sum if is larger. Okay, sum ifs just allows more than one criteria. So in this case, you sum if, and this you got to pay attention to. Here's the range you're going to sum, and then I'm going to apply that same range to this condition and the same range to this condition. So when you start out, unless you're doing something really tricky, if you're trying to sum a range and apply the rules to the entire range, you're going to see that range twice in the beginning. Once to say you're summing, and then once to say this is the range to which this greater than 10 criteria applies, and this same range is the range to which the less than 20 applies. And if you were to look through these numbers, you'd see this value of 12 is the only one that fits those criteria. So I'm doing a sum, but I really only have one value there, and that's how I get my 12. Okay, so lots of math functions. If there's something you want to know how to do, you just search for it and see if it's there. As you start to type functions, as you know, you get helpful hints. So it'll kind of, here, equals sum ifs. And as soon as I put that parenthesis in there, you can see it's starting to explain to me what should be in here. The range first, the sum range, what I want to add up, and then the criteria range that applies to the first criteria, etc. Okay, next set of functions we're going to look at are logical functions. And the important ones I think are if, and, or, and not. Okay, and these three you can use in conjunction. They can, depending on how you set it up, you can set it up with sometimes with one or the other. But let's look at the if statement first. If statement is very powerful. I'm going to say equals if this cell that contains the age of a student is greater than 13. Now it takes two additional arguments. The first is what should it display if that's true. So if this number is actually greater than 13, and I think I'm going to change that to greater than or equal to 13, then you should display a 1, comma. If it's not, you should display a 0. And so you can say, let me turn that black here. You can see that I've actually got a 1 because it is greater than or equal to 13. If I drag these down, it would now be very easy to do a sum and find out how many kids were over 13. So that's one method. Now a little trick here. If I want to copy this into another cell, so I want the same formula in here, but I don't want it to increment. Like if I drag it over, I don't want this to adjust to C2, which it would do naturally. One trick is simply to select the formula and copy it, then hit the escape key so that I don't mess up the existing, go into your next cell and paste it, and you're going to get the exact same formula. Clean that up. Okay, but in this case, I want to know if they're 13 or more, and if their town is RP. Okay, so let's see, how could I modify this if statement to make that work for me? And basically, what I'm doing is I'm putting it through a test to see if they're greater than or equal to 13. Okay, if they pass that test, they're going to get this 1. But what I'm going to do is I'm going to substitute in another test. So they have to pass the second one if they pass the first one. If they don't pass the first one, it doesn't matter. they fail the whole thing, so they get the 0. So here we go. If, and let me finish it up with open and close parentheses, and inside I'll say if this value equals, because this is text I need to put it in quotes, if that value equals RP, and I can give it the same 2 arguments, or I need to. What do you display if it's true? What do you display if it's false? So if it is true, I'm going to put a 1, and if it's false, we'll put a 0. So let's review and see what happened here. Okay, if you're 13 or more, then I check and I see if you're from this town. And if both of those are true, you get a 1. If the second one isn't true, you get a 0. Now, if you fail the initial test, you go right to the 0. So that can be a little tricky. You can see that this child is 13 or older from RP, whereas some of these other children might be 13, but they're not from RP, and therefore they get the 0, so they failed the second test. So what I did to accomplish that is I nested. I put an if statement inside an if statement, and you can put up to 7 total in one cell. And then of course you could continue to process in another cell. Okay, there is an alternate way for a simple thing like this where I'm checking 2 things. There would be an alternate way to do that, and it's using the AND function. So you'd say equals AND, open the parenthesis, and you're going to say that cell is greater than or equal to 13, and that's the first expression. And when I say comma, I get to put in my second logical expression that this is equal to RP. Now in some ways that seems to be a lot simpler. Let me change the color for you so you can see that that's true. So it's simpler, but I don't get to designate what value I want returned. I'm only going to get a true or false, and if I need it to be something else, then I'm going to want to use the if statement. If not, the end statement works just fine. And if you go through these, you'll notice that it works perfectly. So these, actually the zeros match up with the falses and the ones match up with the trues. So you can see that these are 2 different ways of doing the same thing, getting the same information. Now, what if I want students who are either 13 or are from RP? So if they're from this LF, but they're 13, they still get counted. If they are 12 and from RP, they get counted. But if they are 12 and from LF, they don't get counted. So here we go. We're going to say equals or, and I'm going to say or their age is greater than or equal to 13, first criteria, comma, second criteria is that their town equals RP. And what you're going to notice there when I turn the color on is that it's pretty much the exact same statement that I did here, except I've substituted an or for the end. But it does change the results, because here's a 12-year-old from RP who is now counted. And as a matter of fact, a lot of them are adjusted along here, along these criteria. Now, the other function is the not. And frankly, this is when you have probably more choices than the 2 here, and you just want to exclude 1 or more of those choices. So if I had 10 different towns and I wanted to know, and 9 of them were in Bergen County and 1 was not, and I wanted to know who was in Bergen County, I would simply tell them to sum them up or check them and then just exclude or not the other value. So let's come in here and say equals not, and in this case I'm just going to look for someone who's not from town. Okay, so a not equal to RP. And of course I could put a second criteria if I want. But I think at this point you understand how it works. So are they not from RP? No, that's false. They are from RP. Where this student is not from RP because they're from LF. Okay, so those are your logical functions. Useful when combined with other things. They can be, useful to generate data by themselves, but also very useful when used in conjunction with other functions. Okay, we're going to look at some lookup functions, and these are really cool, but can be a little complicated. Okay, our functions here are vertical lookup, horizontal lookup, column, row, indirect, match, and transpose. Okay, so a lot of these are probably not familiar to you unless you've worked with spreadsheets before. So let's take a look at our data. We have a list of names and we have a list of numerical grades. So these are scores. Maybe these are scores for a marking period, maybe they're scores for a test, it doesn't matter. Down here I've constructed a table, and I've done it according to the grade cutoffs. So in other words, if you have up to a 65, if you have a 64, your grade is an F, whereas as soon as you hit 65, your grade goes to a D. As soon as you hit 70, your grade becomes a C minus, etc. I also put in some descriptors in here. So if you fall from 0 to 64, we should call your parent. If you're at 65, we're going to send a letter to your parent, get extra help, all the way on up to just, saying excellent or whatever you want. So this table here just gives descriptive information and letter grades. If you look off to the right, there's a second list. This list includes an awful lot of what's in the first list, but it's not a perfect match, and it's been alphabetized by last name where the first list hasn't. So that's where we're starting from. First thing we're going to look at is a vertical lookup. So what I want to do is I want to be able to pull this letter grade into here dependent on their grade. So equals V lookup, and it's going to ask what I'm going to search on, and I'm going to search on this 96. This is the value I want to use for comparison. Now it's asking what range do I want to search, and I'm going to pick, I'm not going to take the header up here, but I'm going to click all the values in column G, H, and I that have to do with these grades. I'm also going to be smart here, and I'm going to make that an absolute reference so that it's the same when I drag it down for all my other cells. Index. It wants to know, it's going to look in this first column to see if it meets certain criteria, like if it makes at least a 65. And if it does, it'll look again. Does it make at least a 70, 73? And it will stop when it doesn't make the next grade. So if it's an 82, it'll say, okay, it made an 80. Does it make an 83? No. So my information is in this row. And it's going to ask me, which column do I want to return the information from? So this is column 1. This is 2. The grade is actually in 3. So the index I'm going to use is 3. And when I do that, this 96 returns an A, which is no surprise. When I copy that down, let's look at the C+. That's interesting. That's a 78. So let's see, is it above a 65, above a 70, above a 73, above a 77? Yes. Is it above an 80? No. So the information should come from here, and it is in fact the C+. Now I can use that exact same formula, so same trick. I'm going to copy that formula, hit escape, and then paste it in the next cell. So it's the same, so I'm getting the same. And all I have to do is say, in this case, just get me what's in column 2 instead of column 3, and now I'm going to get the comment to come across as well. So that is a vertical lookup. horizontal lookup works the same way, except that instead of being structured vertically, it's structured horizontally. So, just as you expect, no big difference. Just if you prefer to do it the other way. Okay, next thing we're going to look at is this match function. Very useful if you have to compare two arrays of information, two sets of information. So what I'm going to do with the match function is I'm going to check this value and see if it exists in the other list, and if so, where it exists in the other list. And I do that by saying equals match. What do I want to search on? Well, I want to search on this value. I want to see if that's somewhere else. And what range do I want to search? Well, I could select exactly this, but I'm going to do the entire column. It doesn't matter. It's going to look all the way through the K column now, and that's not going to hurt anything because there are just a bunch of blanks below the column. And it doesn't really matter if it's going to search for the word list 2 or the label list 2 because it's not going to find it. Then I'm going to put a comma, and there are different types of matches you can get. In this case, you just want a search type of 0. Okay, just take my word on that. And now you can see that it returns a 28. Well, if I look down here to row 28, I find that that is where the match is. So it's returning the row where this thing exists. And if I drag this down, it's now showing me that, wow, every one of my values exists in this list, and it's giving me the row where they exist. Let's do the opposite. Let me come to the second list. So now I know that everybody in the first list is in the second list. Let me come to my second column, and I'm going to do a match here too. Equals match. I want to match this value, the first value, with everybody in column A. And again, I'll put that 0 for an exact match. And this says, sure, Sid exists on row 10. But when I copy this down, what I find is that I get a couple of NAs. So these are people that exist in the second list, but it can't find a match in the first list because they don't exist there. Okay, so I could always filter these out, and then I would have a list of people. If I was expecting the two lists to match, I could identify my mistakes pretty easily. Now, we're going to use that value from match for indirect. So I want to know in this alphabetized list what Sid's score was, what his numerical score was, or what his letter grade was, or what his comment was. It doesn't really matter. In this case, we're going to do numerical grade. And what we're going to be able to do is we're going to be able to pass in this number to get the correct cell reference. So we know what column the information is in. The column for this is in column B. But we don't know what row we should get it from. So we simply say equals indirect, and this I have to put in quotes, column B, and then an ampersand, and I'm going to say this. So what that's basically going to say is get the value from B10. And it's an 84. So let's see if in row 10, there it is. Yes, it is Sid, and he does have an 84. So I'm able to grab that information in that way, which can be can be very, very useful. Can save you a ton of time. Okay, if you need to. And then, of course, the NAs are still NAs because it's not a match. The other functions in here, we're not going to make a big deal out of, but we can simply, in order to get those row numbers, etc., we can say things like equals column. And then if we pick a cell, we're going to find out that that's in the 5th column. A, B, C, D, E. Yes, it is. Equals row. Where's this thing? Over here. Oh, that's in row 13. And you would find that that's true. Last thing I want to do is I want to show you how to transpose data. So you can do this by copying it and pasting using a paste special transpose, but you could also just come to a cell here and say equals transpose, and I'm going to just select the data that I want to transpose. Let's say that it's this data, and hit enter, and there you go. Now the names are going across the top, and the match is second and the score is third, so it's just flip the data. Okay, last function we're going to look at, last set of information is going to be the info or information facts, and we'll do that now. These functions give you information about the type of things that are in the cells. So there's an is blank, meaning that if the cell's empty, it'll return true. Is an error. So if you've put something illogical in there, it will tell you that. Contains NA, which we saw in the match, and some other functions will be returned, like not applicable. Is an even number, is an odd number, and this will actually give you the next number. Is number, so if it's simply text, then this is going to return false. Is text, same idea. Is non-text, meaning if it's anything other than text. So let's see how that works quick. Over here I can say equals is blank, and let me select this cell, this empty cell, so that is in fact blank, or maybe it's not. Maybe there's something hiding in there. Nope, it's blank, true. So if I drag that across, if I drag that across, you can see that the adjacent cell, because the column is incrementing here, this one does contain information, so it's saying that this cell is not blank. Okay, equals is error. Now I have a division error here. I tried to divide 10 by 1 and it doesn't work. So that's true, that is an error. The adjacent cell does not have an error. Is NA, and you can see the NA in there, so this should return a true. Oop, forgot my equal sign there. And it does return true. The next one does not have an A in it, the adjacent cell, and that becomes false. Now, is even equals is even. To this it will actually return, I think I misspoke before, it'll return a true or a false. It won't round up like the other function. Equals is odd. That's going to be obvious since we know how is even works. You've got is number. 5 is in fact a number, so that's true. The FIVE is not a number as far as the spreadsheet is concerned. It's text. It can't be added. It can't be used in equations. Equals is text, and you can see that the 5 actually is text. Well, that's saying that it's not text. Well, why not? Oh, because I have selected a 7 instead of a 8. So that was an error on my part. So A8 is in fact text, but the number 5 is not. Come on. And last, is non-text, and that is an error. So yes, that is not text, that's true. I'll do one last thing for you to show how some of these things can be useful. Underneath here I have a record. This is my New Year's resolution. I'm going to exercise every day. You can see that on the first it was 40 minutes, on the second it was 20, on the third it was 0, so already I'm kind of losing my resolution. But I bounce back here. Now what I'd like to do in this column is keep a running total. So I'd like to say that this equals the sum. And I don't want to have to, since it's a running total, I don't want to have to write a unique formula each time. So I'm going to say the sum is what's in this cell up to what's in the same cell. Oh, where are we there? B12, okay. So it's everything from B12 to B12, and that's going to be 40. Now I'm going to take that first B12. Oh, it's trying to edit it for me. I'm going to take that first B12 and I'm going to put an absolute value on it. I'm going to do that by hand, I think. I'll just put in the, come on, $, here, and here. Okay, and that was preserved. So now you can see that as I drag down, only this reference will increment. So it's always going to start from the top, and the second number will always be referring to the row that it's in. So this is summing this is summing this, and this will sum the first three. So great. Working perfectly. However, if I drag this formula down so it's going to automatically calculate for me when I enter my information, that's great, but I kind of don't want to see this here right now. So let's see if there's a way we can go step by step to suppress it. So I'm going to start building this in these extra columns, and then I'll move it in. So in this one I'm going to say equals, well, I can do it right up here. Equals is blank, the cell with the time in it, and that's false. And you'll see that it's going to be false for all my entries until I hit the ones that are empty, and then that's going to be true. So let's see if I can build a formula over here. I can say equals if this equals true. Okay, so if it's blank, that's what that's saying. Open and close your quotes and it'll display nothing. Else, let's try, I'm just going to put any character in there, an X. So you can see that it displays nothing here now, but for anything that's populated, it displays an X. That's useful to me. I can suppress what's in a cell based on what's in another cell. Okay, so let's see if I can put this all together. D16 equals true. So I think I can just incorporate that into the same formula. I can take this is blank, and I can get it in this formula. I can say if is blank B16 equals true, suppress it, otherwise do X. And let's see if that worked. I don't see anything there. And when I drag it up, okay, that seems to be working exactly the way I want it. So my formula is coming along. Now, the fact is that I don't really want to, I want to suppress it, but I don't want to display an X. I want to display this number. Well, I know where to get this number. This formula is right here. So what I can do is I can say instead of the X, let me just paste in the calculation. Again, nothing appears. It's being suppressed because this is empty. Oh, and it's showing the data here, which is perfect. And if I actually type 8 minutes worth of exercise in there, it appears. Perfect. So this is the formula that I want. And I want this formula in here. So I'm going to copy that, hit escape, come into this cell, paste it. Let's see if it works. I drag it up, and that works outside of the fact that I lost my borders. And if I drag it down, that works too. Now I no longer need any of this. Okay, that last thing was just both a demonstration of how these functions might be helpful to you in certain circumstances, and also the process of kind of building out something that's a little more complex and how you can do that. So I hope you found this useful, and just know what some of these functions are so you know what it's capable of doing, and you can do a little research and playing around at the time you need them. You don't have to memorize all these, you just kind of have to know what's possible.